Hello everyone. In this video we will be deriving an expression for kinetic energy. So as you already know that the expression for kinetic energy is half mv square. So now let us derive. Now we have to suppose that the object initially is at rest having mass m, and we have to apply the external force on it to set it in motion. So when we apply the force on the object, then it will start moving with a velocity v. So let us write. Let an object of mass m starts from rest and attains a uniform velocity v after a force F is applied on it. Let during this period the object is displaced by a distance s. So when we apply the force on the object moves and it is displaced by the distance s. So the work done in displacing the object is given by force into displacement. So let this be equation number 1 because we have to use this equation later on. Now, using the third equation of motion, so there are three equations of motion as you have already studied in the chapter motion. So first equation is B equals to U plus AT. Second equation is S equals to UT plus half AT square. And the third equation is B square equals to U square minus 2AS. So here we are going to use the third equation, that is B square equals to U square minus 2AS. From this equation we get S equals to B square minus U square by 2A. So this we are shifting to left, and this 2A we have to divide B square minus U square, and then we get S equals to B square minus U square by 2A. So let this be equation number 2. So using the third equation of motion, we have got an expression for the displacement or distance. So we're gonna replace this later on in equation number 1 here. But still we don't have the expression for force. Now the force by definition it is mass into acceleration. So let this be equation number 3. So now we have to replace this force and displacement by the expression from equation number 2 and 3. Using equation 2 and 3 in 1, so replacing the value of force and displacement from equation 3 and 2 here, we get work done equals to this force means mass into acceleration from equation number 3 into displacement means B square minus U square by 2A, which is from equation number 2. So we have got this expression. Now here we cancel this acceleration AA, and the remaining will be this 1 by 2 half this m and within bracket B square minus U square. So this is the work done. But if the object is starting from the rest position, then its initial velocity, that is u, will be 0. Then if we replace this u by 0, then the expression will reduce to w equals to half m b square, because this initial velocity is taken as 0. Now this work done is equal to the change in kinetic energy of an object. So work done in this case is equal to kinetic energy. This expression for the work done is same as the expression for the kinetic energy. So kinetic energy Ek equals to half mv square. So this is the final expression for the kinetic energy. So here we have obtained this equation by considering initially the object is at rest. That is, here we have taken initial velocity is 0. So if the initial velocity is not 0, then we have to write the expression for kinetic energy as half m b square minus u square. The same expression like here. So this is for initial velocity 0, and if the initial velocity is not 0, then we have to write kinetic energy equals to half m within bracket b square minus u square, where there is initial velocity also. Just before we have derived an expression for the kinetic energy, which is half mv square. Now let us derive an expression for the potential energy also. The potential energy by definition is an energy possessed by the virtue of its position or configuration. So here let us consider an object on the ground. So at this position of an object, the height from the ground is 0, so that this object has a 0 potential energy. Now, if we lift this object to a height h by applying the force, that means we have to do work on it to lift the object. So we are spending our energy to lift the object. So if we lift the object to a height h from the ground, then the energy that we have spent on this object to lift it at a height h will be stored as a potential energy. And at this position, another force is acting on it. That force is weight. So as you already know that expression for the weight is mass into gravitational acceleration, which is directed towards the center of the earth or towards the ground. Now let us derive the expression for that potential energy. So consider an object of mass m be raised through a height h from the ground. The object gains energy equal to the work done on it. Then the work done is given by the expression force into displacement. So here the force, as I have already told you, is the weight of the object, which is mass into gravitational acceleration. So this force is given by mass into gravitational acceleration, and displacement here is the object has been displaced from the ground by height h. So this h is the displacement. So altogether we get the expression for work done as mgh, mass into gravitational acceleration into height. Now as I have already told you that this work done will be stored as a potential energy on the object. So we can write this work done is stored in the body as potential energy, and potential energy represented by EP equals to mgh. So this is the expression for the potential energy.